supplies direct current. The other is the big function generator on the back table, which we used, I think, twice. Correct me if I'm wrong. To turn this on, there's a switch here. Nice and easy. There's a high side, color-coded red, marked with a positive. There's a low side, color-coded black, marked with a negative. We also use this multimeter for almost everything. This can measure anything you need it to. There is voltage, direct voltage, and alternating current voltage, these top two. Direct and alternating current, these bottom two. This guy, which is an omega, is for resistance, that's ohms. This one that looks like a capacitor is for capacitance. You turn this on here. To measure voltage, which we did most, you measure across a component. If you're measuring the voltage across this resistor, you put these on either side of the resistor. If the resistors are in series and you want the series resistance, you put one lead at the beginning of the resistor and the other at the end. And that gets you the resistance across this group of components. If you've got them wired in parallel, you can go corner to corner to get the voltage drop across the parallel resistor. Either corner should work. You can also measure resistance the same way for resistors. This is series. Your power supply comes in on the high side, and then you physically trace through the circuit. So you get current coming in here. It runs through this resistor. When it gets to this node, it has only one choice to go through this cable. Here, it has only one choice to flow through R2. Here, again, only one choice, all the way out, and then you return to your power supply. Okay?
That's series?
That's series. For parallel, you're given a choice. Here, R1 is in series with a parallel resistor made up of R2 and R3. So here the current comes in on R1. Through R1, here it has no choice, it has to flow in here. At this point there is a choice. You can go either through this cable or through R2. If you return here, then you're going to go through this cable and immediately back to ground. You skip both resistors. If you return here, this forces the current through both paths. And so now you have R1 in series with R2 and 3 that are in parallel. Okay, last thing, measuring current. To measure voltage, you're going across components. You drop this in at the end, over the two ends of whatever you're measuring. To measure current, usually done with this guy, you need to know if you're using direct or alternating current. Usually, it's direct current. It's the final measurement. It's got a straight line across. This little wiggly line that looks like a sine wave is alternating current. This ammeter needs to be plugged in series. It basically means you're going to insert this along one of these lines. If we could split this wire and send one of its ends in here and the other end in here, that would be good. We can't, so instead we're using these ends. Here's the idea. Power is going to run in here, in series through R1, and then if we wanted to measure the current through R1, we would pick it up after it goes through R1. That current runs through this wire, through the ammeter, and then back into the circuit. The current doesn't have a choice. It has to run through the ammeter. That's the only way this device works to measure current. To measure R2, for example, and this is the node loss setup, you set it up like this. Current would come in here through R1, through this cable. Now here it's a node. The current has a choice. One of the choices is to run through the amp meter backwards. So it runs through this wire, through the ammeter backwards, and then back into the circuit here. The circuit's grounded over here, so then it would move through R3. Here you're picking up the current just before it goes into R2. And the way it's set up, it's running through the ammeter backwards, so you pick up a negative sign as well. For R3, you're gonna look like this. Similarly, you're coming in here, through the node, into the ammeter, through the ammeter backwards, and then into R3. You're reading the current just before it goes through R3. It's running through the ammeter backwards, so you pick up a negative sign. For the node law, the current through R1, where it's all of the current, should equal the sum of the currents through R2 and R3. And the way we've set up the circuit, this is a positive current, these two read negative, so the sum should equal 0. Questions? Okay. Any other circuits?